So this last one, 270, we could go through the same thing, but again, 270 is going to be quite a bit more difficult because not only would you have to do 180, but then you'd have to add on another 90. So you can kind of see how it could be complicated where you'd have to do like 180 plus 90. So I'm just going to go ahead and give you the rule on this one. We bring the y to the front and then we do opposite of x. So we're going to switch them and just do opposite x. So if I were to write down the coordinates of, let's say, A, this would be -1, 4. When I switch these, it's going to become y first, then opposite x. So that would be my new location. So 4, -1, which again does make sense because if we do 180 and then if we do 90, okay? So let me go ahead and write down the coordinates of B, C, and D. And then we'll just apply the rule. So we're going to bring the y to the front and then opposite x. Y to the front and then opposite x. And then y to the front, opposite x. Okay? And then we'll just go ahead and graph those. So it's hard sometimes when they don't line up on perfect grids to get the exact same shape. So my shape looks a little bit off, but it might be because some of these, like where it's 4, -1, it looks like I'm a little bit lower than probably halfway, but that's okay. We kind of have the basic idea. And again, if you use your tracing paper, if you put your tracing paper here, and then we put our pencil at the origin, now this would be, again, this would be your 180 plus another 90 degrees. Whoops, I just slid. Plus another 90 degrees. Do you see how we're in the right location? And again, they're pretty close. It's just because of, like I say, some of these halves where they don't line up on a grid. Okay? So out of anything, I really think these rules right here, these are probably the more important ones that I would say you probably need to memorize because they're a little bit harder to graph. Okay? When we go to the next page, notice on this next page, we really just have compositions, and then we have symmetry, again, very similar to what we saw yesterday, okay? So when we do this, notice the original is already graphed for us. So when we do this one, we have to make sure we go in order, okay? So the first thing we're going to do is we're going to reflect over this axis, and then we're going to rotate. Now, again, I can do this on the grid if you want. I can reflect this over the X, so it would go down here, and then I would rotate it. But honestly, I almost think it's easier if you just, again, write down your coordinates. And again, why do they have to give us graph by 2? But it is, okay? So we get to do our coordinates. So now the very first thing we're going to do is we're going to do the x-axis rule. And if we were in class, I would be asking you, what is that rule? And the x-axis rule is you only change the y coordinate. So we just need to do opposite of y. So we're not going to change the x, and then we're just going to do opposite y. We're not going to change the x, we're going to do opposite y. Okay, so we just applied the rule. Now, we use these ordered pairs, so we don't go back to the original. We're going to use this ordered pairs, and now we're going to apply the 180 rule from the front side of our page. Okay, so if we look at the 180 rule from the front side of your page here, notice it's opposite x and opposite y, so we're going to change both. So again, we're not going to switch the positions, we're just doing the opposite. So we're going to do 4, 4, and then we're going to do 1, -2. This is the final answer. This is the only one you have to graph. So this is like m double prime, because this would have been m single prime and n, mn. And then this would be n double prime. So if I graph that, here's my final answer. Now, if you notice, it kind of looks like it's just a reflection over the y-axis, okay? But we did 2 at a time. So why don't you pause the video here, and why don't you try 6? All right, hopefully you paused the video and tried it on your own. I'm going to quick go through it. So the first thing I'm going to do is the 90-degree rule. So the 90-degree rule is going to tell me to bring the opposite of y comma x. So I'm going to do 1 comma negative 2, and then negative 1 comma 3. I have to kind of think about it for a minute. Okay, so this is the 90. Now I'm going to do, a translation. It's been a day or two since we've done these. Now translation, remember, we're just going to add that number to the x. So I'm going to go 1 plus 2, and then I'm going to plug my y in, so negative 2 minus 3, and there's my new coordinate. So I'm going to do the same thing here. So negative 1 plus 2, 3 minus 3, and now this is my final answer. That's the one I'm going to graph. Remember that these are by 2's. And then there it is. Okay? So that's a composition. Now, in number 7 here, they're using number 6, and they're asking you, is if you were to reverse the order, would it make a difference? So if you take a look at this, notice the translation is the same, the rotation is the same, but what they're doing is they're switching it and making the translation first. So the coordinates are the same for M and N. So I'm just going to recopy those. Okay, so those are the same coordinates. Now I'm going to do the translation first. So I'm going to add 2 to the x, and I'm going to minus 3 from the y. Okay, so I'm going to add 2 to the x, and then 1 minus 3. So this is my translation. Now I'm going to do the rotation of 90. So the rotation of 90 is I'm going to bring the y first and do opposite, and then the x stays the same. So y first and opposite, and x stays the same. Notice that these points here and here are totally different. Those are totally different locations. So the question down here is kind of the big underlying question, and I really already gave you the answer, but does the order matter? And the answer is yes. Now, it doesn't always matter. Some combinations, like for instance number 5, this order actually does not matter because it would land in the same spot, but it's only because of really the 180. But now anytime you deal with translations, no matter what this number is, even if it was 180, it would make a difference. So I guess I would just tell you, stay in order, okay? And if you want to graph that, you can, but I just want to show you that the numbers were different. All right, the last piece here is the other type of symmetry. We talked about this in yesterday's lesson. So rotational symmetry is basically when you can turn, I'm just going to say a figure, but it could be an object. So turn a figure to match up on itself. Okay, but the key here is turning. The center of symmetry is the point of rotation. That's not a huge deal, but sometimes kids will kind of wonder, sometimes kids will kind of wonder, like, where are you turning it? If it's on a graph, it's the origin, but sometimes you'll see on the next page when they're not graphs, it's just where do you turn it from. So if you look here, we just have 6 examples left, and basically what they're asking you is, can you turn this to get it to match up on itself? So I'm just going to call this the top. Okay, it doesn't really matter what you call as a starting point. I'm going to put my tracing paper over top of this. And I just filled in top. Now, if I were to hold it here, it would be kind of goofy because do you see how it kind of turns? So in this particular case, the center of rotation more than likely is in the middle. So let's hold it in the middle and let's see if we turn it. Does it ever match up? And notice, can kind of slide on me, but do you see how it's upside down? So that is 1 turn, and that is 2 turns. So basically you can turn this 2 times. Now be careful. That's not actually the question that they're asking you. So they're asking you, does the figure have rotational symmetry? So I would say yes, it does. Then the next question they're asking you is, if so, describe any rotation that mapped onto itself. Now, I wish it was a little bit more specific, and I know maybe it is in the book, but they are usually asking you for the angle. They want the angle. So how you find the angle is basically you take 360 divided by the number of turns. So I can turn this 2 times. So if I go 360 divided by 2, that's 180 degrees. So that's how we know the degree of the turn. Now, if you can only do it 360, so I'm going to jump to number 13. If you can only do a 360 turn, we typically say that does not have rotational symmetry. So if you watch the trapezoid, notice if I turn it, it doesn't match up unless I go all the way back around. So if there, again, is really only 360, we would say that this has no symmetry or rotational symmetry, because it does have line symmetry. If we were to cut this in half, it would fold, but it does not have rotational symmetry. So if you want to pause the video here, there's just 4 more to try. Why don't you give them a try? And again, if you don't have tracing paper, you can always go to the kitchen and see if your mom has wax paper or parchment paper. That's pretty much the same. All right, hopefully you tried it. An octagon has 8 turns. Whoops, I guess I should say yes, it does have it. And it had 8 turns. So if I take 360 divided by 8, I get 45. So basically what you're telling me is every 45 degrees, and again, I don't have a protractor here, but every 45 degrees, boom, it matches. Boom, it matches. Matches. So that would be 45 degrees. All right, a rhombus has 1, so we're at 180. This type of an octagon, which is a goofy shape octagon, note it's a regular versus an octagon. This octagon has 4 at 90. So, sorry, I have a habit of always putting the number. If you don't want to put the number, you don't have to put the number. You can just say yes. I have a habit of always saying the number in my brain for some reason. But there's 4 turns, 1 turn. And then a right triangle, even though we love our right triangles, actually do not have rotational symmetry. Okay? And so that ends rotations.